All right, this is section 4.7. We're going to try and make this work. I've done this before. We're going to do our best here, and hopefully we get through this okay, and hopefully this is beneficial for you guys while I'm out. So section 4.7, the quadratic formula. Just to pick up where we left off, right now what we're trying to do is we are finding solutions to quadratics, okay? And remember, when we're talking about solutions, I mean that in a couple ways. Those are also known as zeros or x-intercepts. It's all kind of the same stuff, right? And so far, to find these solutions, we've looked at factoring, right? We take our quadratic, break it down into factors, and that gives us our zeros. We've also looked at graphing. When we graph something, when we graph a quadratic, we get those x-intercepts. Those are our solutions. You should have, in 4.6, looked at completing the square. That's another way to get your answers. And today is a new one, the quadratic formula. Something you should have seen in Algebra 1. But this is as it says here, one of the most foolproof ways to find the solution to a quadratic. Okay, we use this formula here, and I know it looks kind of crazy with B's and A's and C's and stuff going on like that, but it's really helpful when we have a quadratic in standard form. So let's go down and look at that. Ax squared plus bx plus c, right? Standard form, a, b, and c. When sometimes we have a quadratic like this and it's not easy to factor, it might be like really annoying to graph for some reason, or completing the square is not a good option, we can always use the quadratic formula. To use it, we plug in the values for a, b, and c to their appropriate spots, okay? So let's go ahead and take a look at this first example. What are the solutions of 2x squared minus x equals 4? Well, like I just said, we want to get it into standard form. So let's make sure we get a, b, and c on the same side. To do that, I need to subtract 4. Okay, so I'm going to set that up, and then I can clearly establish what my a, b, and c values are. A is going to be 2, b is -1, and my c value is -4. Wonderful. Now, we're taking our quadratic formula, that big ugly thing from above, right? We're going to plug all of these a, b, and c values into that. So -b plus or minus the square root of b squared minus 4ac over 2a. Okay? So, notice that right off the bat, it's opposite of b. So right now our b value is -1, which means when we plug -1 in for b, we're going to get +1. So I've got +1 plus or minus the square root of b squared. That would be -1 squared minus 4 times my a value, which is 2, and my c value, -4, over 2 times a. Okay. Now we got to be very careful with negative signs, squares, all that kind of stuff. Okay, this is just about being organized. This isn't like super complex. So this becomes 1 plus or minus the square root of, what's -1 squared? Well, that should be 1 minus 4 times 2 times -4. 4 times 2 is 16. Or sorry, 4 times 2 is 8. 8 times -4 is -32. And all of that is over 4. So then, make my little arrows. So then we get 1 plus or minus the square root of 1 minus -32 is 33 over 4. And that is our answer. Okay, now it looks kind of goofy, but let's notice a couple things. First of all, there are actually 2 answers in that, right, because of the plus or minus. So that means our 2 answers are either 1 plus the square root of 33 over 4 and 1 minus square root of 33 over 4. Okay. Another way you might see that expressed is by breaking up the fraction. So what I mean is like this: 1/4 plus or minus square root of 33 over 4. For this particular problem, that's not any cleaner or easier, but occasionally there will be some times where splitting it up might actually simplify things, make it look nicer, whatever. Okay. So that's the first example. Let's go to the next page. And we have another one. What are the solutions to x squared plus 4x minus 3? So again, the whole reason we use this quadratic formula is because we're trying to find the solutions, but we're running into a wall if we tried to factor this, right? Like, if you try and break this thing down into factors, you might think like 3 and 1 or something, maybe? You might try every combination of that, but because you think 3 and 1 are going to add to 4, but you can't get the right plus or minus combo, so it just doesn't quite work out like that, okay? So that's why factoring isn't going to be very helpful here. Completing the square, also not going to help us out too much here because we got to keep it in standard form. So let's go ahead and use the quadratic formula. My a value is 1, b is 4, and c is -3. So let's plug that stuff in accordingly. We get the opposite of b, plus or minus the square root of b squared, minus 4 times a times c over 2a. Alright, again, I know it's just kind of ugly, but really this isn't that complex. We just got to stay organized. So we got -4, plus or minus. The square root of 4 squared is 16, minus 4 times 1 times -3 should be -12 over 2. And that takes us over here to -4, plus or minus the square root of 28 over 2. So now again, we can leave our answer like that, but this one, I think is an example where splitting it up is a little helpful, okay? Reason for that is because when I have -4 over 2, that's going to simplify down, okay? -4 over 2 is -2. And then we got plus or minus radical 28 over 2. Square root of 28, we haven't talked about this too much. We will talk about it more here coming up. That thing breaks down, I'm going to do it up here, into the square root of, we can think of it as 4 times 7. And when you have that, we can think of that as the square root of 4 times the square root of 7, which the reason we break it like that is so we can get a whole number in front. Now, back down here, we're at -2 plus or minus 2 radical 7 over 2. I'm just making that radical 28 and turning it into 2 radical 7. Okay. Now the reason for that is, well, now the 2's are going to cancel. So that leaves us with, let me come down here to some clean space, -2 plus or minus the square root of 7. And that is our final answer. Okay, so again, this whole thing, the only reason it's troublesome is if you have trouble staying organized, simplifying, keeping track of those negatives, squares, square roots, all that stuff. So far, so good. The quadratic formula is also useful, though, to tell us how many solutions exist for the given equation. For this, we need to analyze the thing called the discriminant. Not the discriminate, that's a bad word. Discriminant is the thing that's under the radical, okay? As you can see here in the box, it points out the discriminant here is the value of the expression b squared minus 4ac. And like I said, we're always going to find that in these quadratics under the radical, okay? Now that value here is going to tell us if the equation has 0, 1, or 2 solutions, okay? That's what I'm saying down here at the bottom. If a quadratic has 2 solutions, let's think about what that graph's going to look like. That means it has 2 x-intercepts, right? So the graph's going to be a parabola that crosses the x-axis twice. Now, if it only has 1 solution, that means it only crosses the x-axis once, which is kind of goofy. In these, it's going to come down, just barely touch it, and come right back up. There's only one x-intercept. There's 1, 0. And if it has 0 solutions, well, then it never crosses the x-axis. So it's a parabola that maybe looks like this, where the vertex is up there, or maybe it opens down, and the vertex is down there, right? There's no solutions. Okay, so those are our 3 options here when we're looking at the discriminant. On the next page, it goes a little bit more into detail about how the discriminant tells us that. If the value of the discriminant in this first box here is positive, or as it says, greater than 0, we get 2 solutions, okay? And as the graphs over here showed what I just had on the previous page, they cross the x-axis twice. If the discriminant, b squared minus 4ac, equals 0, that gives us one real solution. In that case, the graph has one x-intercept. And finally, if the discriminant value, the b squared minus 4ac, is less than 0, if it is negative, then there are no real solutions, okay? So there are no x-intercepts. And we're not really concerned about what exactly the value is. We just want to know, is the discriminant here positive, is it 0, or is it negative? Okay, that's all we're analyzing. So in this example, it says how many solutions are in the equation negative 2x squared minus 3x plus 5. And so the question, how many solutions, we've got to just focus on the discriminant. We're not worried about factoring. We're not worried about doing the whole quadratic formula here. All we're worried about is b squared minus 4ac. And then figuring out, is it positive, is it negative, or is it 0? That's going to tell us the answer, how many solutions, right? So let's go ahead and identify. What's my a? That would be negative 2. My b value is negative 3. And my c value is 5. So let's plug that stuff into the discriminant, b squared minus 4ac. So that'll be negative 3 squared minus 4 times a times c. Negative 3 squared is 9, minus 4 times negative 2 is negative 8. Negative 8 times 5 is negative 40. 9 minus negative 40 is 49. Now again, who cares about 49? The fact here is that it's positive. Okay, so since it's positive, that means we have two real solutions. Okay. And the last one here, how many solutions in the equation 2x squared, minus 3x plus 7? Okay, so we want to plug it into the discriminant. My a value here is 2. My b value is negative 3. My c value is 7. So I'm going to get negative 3 squared minus 4 times a times c. 4 times 2 times 7. Negative 3 squared is 9. Minus 4 times 2 is 8. And 8 times 7 is 56. 9 minus 56 equals negative 47. So it's negative. Again, who cares if it's negative 47 or negative 5 billion? The fact is it's negative, which means there are 0 real solutions. Okay? So that's a big part of this whole thing, figuring out what the solutions are from the quadratic formula, but then also figuring out how many solutions are by looking at the discriminant. Okay? That's all for 4-7. Talk about the homework in class here. Okay, good job.